When people say AI agent, they mean two things bolted together, a model and a harness, the code that lets it actually do things. A new open model small enough to run on your laptop does something clever. It writes its own harness, and its benchmarks claim it's far better than the free model it was built from. But that's the catch. It is just a fine-tune of that free model. So the honest question isn't, is it good? It's, is it actually better than the free thing it's built on? Enough to bother? I ran both, the same tasks, the same setup, on my own machine. What I found isn't what the benchmarks say. Start with the harness because everything turns on it. A model alone only produces text. To make it act, you wrap it in a harness. The plan, the tools it's allowed to use, its memory, and the logic for what to do when a step fails. The model decides what it wants. The harness carries it out and feeds the result back. That loop, decide, execute, observe, continue, is what turns a chatbot into an agent. Normally, a person writes that harness once and freezes it, general purpose, so never tuned tightly for any one job. This model's trick is that it writes the harness itself, a fresh one per task. It reads the job, produces a small piece of scaffolding that plans the steps and wires up the tools, then solves the task inside its own structure. It was trained to do this, rewarded not just for good answers, but for authoring the orchestration that gets there. And that's the number worth testing. Its makers say the fine-tune is dramatically better than the base it came from, but the only honest way to know is to run them side by side. So that's exactly what I did. One thing to know if you run it, it's a reasoning model. It thinks before it answers. Beyond that, running it is like running any local model. For the test, I built a deliberately minimal agent, just 3 tools, and put both models through the exact same one, same tools, same settings, same tasks. I swapped only the model. A bare harness on purpose, so whatever each model does, it's the model doing it, not some framework doing the work for it. Whatever difference shows up is what the fine-tuning actually bought. I gave them 4 everyday coding jobs, the kind you'd actually hand an agent. Write and run a script, read a file and compute from it, find and fix a bug, implement a function and pass its test. Same tasks, same tools, only the model changed. Here's the surprise. On all 4, they did the same thing. Both wrote working code and ran it. Same correct output. One wrote a terser script, one a fancier one, but the result was identical. Both read the file first, then computed the right numbers in the same sensible order. Both found the same bug, a wrong divisor, fixed it, and here's the part that matters. Both reran the script to check rather than just claiming it was fixed. And I set a trap on the last one. The test only checked 3 numbers, so a lazy model could just hard code those 3 and pass without actually solving anything. Neither did it. Both wrote real logic and both correctly said 9 isn't prime, a case the test never looked at. The fine-tune was specifically trained to resist that shortcut, and it did, but so did the plain free base. I even tried to break them, an open-ended prompt with barely any room to answer, hoping they'd think themselves into a corner. Neither did. Both just wrote a real answer the limit cut off. 4 everyday tasks, and the expensive fine-tune and the free model it's built on did the same thing, equally well. There was exactly one place they diverged. I asked for something bigger and open-ended. Design and build a caching system with code. The fine-tune did something the base didn't. It organized the work into a proper multi-file package, separate modules for policies and metrics, like an engineer laying out a real project. That's its fingerprint, and it matches the claim that it plans like a coding agent. The base just wrote one big file. So, point to the fine-tune? Here's the catch, and it's the honest heart of this. Neither of them actually ran its own code. And when I ran it myself, the fine-tune's tidy package imports a module it never wrote, so it breaks. The base's single file has a syntax error, so it breaks too. Both handed me confident, professional-looking code that doesn't execute. So the difference is real, but narrow. It's how they organize a big job, not whether the job works. And there's the thing worth remembering about small local agents. They'll give you plausible, well-structured code that's never been run. Check it before you trust it. So, is the fine-tune better than the free model it's built on? On everyday agentic work, the tasks you'd actually give it, no. They drove the tools the same way, got the same right answers, checked their own work the same way, and resisted the same trap. The costly fine-tune's edge didn't show up, and the free base was already good enough. One honest limit in both directions. My tests were realistic, but not brutal. The small, well-defined jobs most people actually run. The benchmarks that claim a big gap use much harder repo-scale work, and it's entirely possible the fine-tune pulls ahead there. So this isn't the fine-tune is pointless. It's on ordinary tasks, its advantage didn't appear, and you may need genuinely hard problems to see what you're paying for. Which lands on the question worth carrying. Not, what's the newest, most hyped model, but is the free or smaller option already good enough for what I actually do? Here, tested honestly, it was. Don't take the launch benchmark's word for it. Run your own tasks, and whatever writes your code, run it before you trust it.